Okay. Tablet properties. All right, so nothing. There we go. Mapping. Manager. 3. There we go. First prompts. Good. Okay. Grades. Which grades? For the test? For the test, yes. They will be posted on the test. The work in the test is due tonight, so I'll be reviewing the test over the next couple of days. So Thursday is the earliest, Friday at the latest. There we go. Okay. All right. So finally have a working pen. I am so sorry. Yeah, so they'll be entered then. What I was saying when we found out you couldn't hear me was that I looked at the videos. Was everybody able, or everybody saw where I posted some videos for difference quotient? Oh goody, my alarm is back. So here was an example. I had 4 difference quotient examples. I think I posted 3 on YouTube. How do we feel about those? Do we want to look at one of these before I get you into 2-1? Because yeah, with just since I've lost the whole first 15 minutes of class, I doubt we're going to get into 2-2 today. So I do want to make sure we're feeling confident with this. So let's look at one or two of these. 3 over x plus 1. I'm just going to copy this blank. This is a blank screen and add it to the test. So here's the problem. I retitled this example f of x, and the reason for that is there's an h as part of the difference quotient. So let's grab the process and let's walk through one of these together, and then we will see how everybody feels. All right, so I have let's do this instead. I'm going to grab both of these because they're on the test and I'm just not super duper confident that everybody's looked at them. So let's go chase this down first. All right, just thrilling stuff here. All right, so here's the difference quotient. So we talked about it just very slightly in class. Touch feature. All right, that's something to get used to. So I've got the difference quotient. It's f of x plus h minus f of x all divided by h. And I've given you, in this problem, g of x. All right, so g of x is 5x squared minus 2x, and I want you to find the difference quotient for this function. The difference quotient for itself, by itself, really doesn't make any sense. It's the difference quotient of a function. So yes, the difference quotient here has f, is the title of the function f. This is called g. That's okay. The process behind this is first step is I'm going to find g of x plus h, whatever the title of your function is, that's the title that you're swapping out. G of x plus h literally means everywhere there's an x, swap it out with x plus h. Fine. And if there's math to be done, we do it. So that's 5 times x plus h times x plus h minus 2 times x plus h. I'm going to multiply the x plus h's times x plus h's, then come back with the 5, just to make my life easy, because we know when I multiply x plus h times x plus h, it's first term squared, the last term squared, and the sum of the two. And I think I did this in class, but that's okay. Distribute that 5. That's 5x squared plus 10xh plus 5h squared. And then distribute that minus, so that minus 2, so negative 2 times x, negative 2x. Negative 2 times h is negative 2h. And that is step 1. All right, so I found the difference. Or excuse me, I've found g of x plus h. Second step, let's find g of x plus h minus g of x. All right. So g of x plus h is everything I just wrote. So I just rewrite plus 10xh plus 5h squared minus 2x minus 2h minus, and then g of x is the original function. The original function is 5x squared minus 2x. And then we say, does anything subtract? Well, yeah, 5x squared minus 5x squared is 0. Negative 2x minus negative 2x is negative 2x plus 2x, which zeroes out. And the only thing I'm left with is 10xh plus 5h squared minus 2h. Everything else is gone. All right. If I did it right, everything here is probably going to have a factor of h in it. And it does, right? So step 3 is find the whole thing. The entire difference quotient is g of x plus h minus g of x, all divided by h. What's that look like? Well, since I broke the process up into 2 pieces, part 2 is the entire numerator. And then the denominator, the difference quotient, is just h. And again, if I did this right, everything in the numerator has a factor of h. So I'm going to pull one of those h's out. And divide. And now I'm left with 10x plus 5h minus 2. And the last step of the directions for difference quotient is you know you're done when you can plug 0 in for h and you do not divide by 0. If I plug in 0 for h, do I divide by 0? Nope. So I am good. All right. So anything else from chapter 1? Any other questions, concepts, ideas, interests? No? All right, so please don't forget to submit the work as well. The tab for submitting your work is in the week 11 weekly, and under the weekly lessons under week 11, and it has it there in the title. So if you will just please make sure that test number 2 is chapter 1 test. Please make sure you submit that. Even in odd functions, okay. Was there a problem from Alex review. Over here. Let's go in here and see. Was there a specific problem, Tinny, or is it just that concept? Concept, okay. So even and odd is so even functions have the feature that if I plug in negative x into my original function, I end up with the function that I started with. Odd functions has the property that if I plug in negative x into f of x, what I'll end up with is the negative f of x. Examples of the even function are parabolas, right? If I plug in negative x, I get back whatever I originally started with. An example of an odd function is a cubic. So it looks like this. Okay. We also talked about their symmetry. If I have an even function, this is symmetric about y-axis. And if I have an odd function, it has symmetry the origin. Okay. The other thing that we found out was if I had a problem, so if I gave you f of x is equal to 3x to the fourth minus 6x squared plus 3, if all of my powers of x are even, the function is even. If all of my powers of x are odd, then my function is odd. If there's any mixture, if there are, and let's get rid of the constant here just because I don't want to confuse things. If all my terms have an even power of x in them, this is going to be even. If all of my terms have an odd power of x, 7x to the 7th minus x cubed plus 3x, like this, all of the powers are odd, so this function is odd. All the powers are even, this function is even. Why is that? Because even functions say if you plug in negative x, you get out the original. All these places where I'm squared, or when I'm raised to the even power, that x to the fourth is gonna tamp out that negative, right? Negative x times negative x times negative x times negative x is positive x to the fourth. Negative x times negative x is x squared. And the odd, when I plug in a negative if I plug in negative x to the 7th, this becomes negative x to the 7th. So that entire term changes sign, and that will happen on every single term in the problem. Okay? And then just don't forget that if you have 3x squared minus 6x plus 4, I have even here, there's an understood power of 1 here. So this power is even, this power is odd. If there's a mix, then the entire function is neither even nor odd, right? So you have even, odd, or neither. All right. What else? Nothing? All right, so I know a lot of folks haven't gotten into the test yet. Just please get in there, make sure you start the test. You get 2 hours for 16 questions, so just make sure you get in there and give yourself plenty of time. Make sure your lockdown browser, make sure everything on your computer is working like you want it to. The test is due today. So yeah, so it's got to be done by tonight by 11:59. If you have, so you have 2 hours to take it. If you start the test at 10:30, it will cut you off at 11:59. So please make sure you start the test, and give yourself that 2 hours. Yes, work just has to be submitted within 24 hours of submitting the test. That's just an easier standard for me to keep. But I did notice, and this isn't you, but in my other online class, I noticed a tendency for students. I would come back and look at their work, and their work wouldn't match up what they submitted because they went back and reviewed the test and then put the correct answers in their work. I don't want to see that. I just want to see the work you did when you did the problem. Don't show me that you know what the right answer is now. Just show me the work you did while taking the test. Please order it so it's easy to read. Please label it so that I know what the work has, whatever number you're working on. Don't just kind of go all over the place in all the directions. This is not meant to be scrap paper. This is meant to be work to turn in. So please treat it as such. All right. All right, so let's get in. Oh. Okay, yes, Sadie, thanks for letting me know that. I noticed a couple of people are popping in and out, so I just kind of chalked it up to Mondays, but it's Tuesday, but it just feels like today just feels like an extension of a Monday to me. All right, so the notes that I posted and the notes you see are going to be slightly different. I try to keep all the questions the same, but you can see the graph here is red. I don't have the title in it, but know that what I'm doing is I'm taking the notes are in Smart Notebook and I'm taking them over to OneNote so that I can write on them in a way that everyone can read. So excuse me if there are some minor changes or issues, but they're going to be fixed. Before we jump into this, though, I'm sure everybody got the email already. The calendar for the rest of the semester is jam-packed, which means so today on the calendar, the first day I really wanted to get into 2-1 and 2-2, and that's not going to happen. So if I don't get through the material, that's going to mean I'll need to make a video after class, and then I'll need you to watch it. So please know that that's chapter 2 is all about polynomials, and really at the end of chapter 2 you're going to be able to sketch and find the zeros and all that stuff. Is it? Yeah, I see you pop in and out also, Andrew. So let's jump in. This is 2-1, first page. The title of 2-1 is quadratic functions and applications, and here is our problem. Function h of x is equal to negative 3.24x squared plus 242.1x minus 738.4. And this models the number of individuals whose age is x and who engage in hunting activities. All right. That really feels like it was written by a mathematician because it's just an oddly worded question. So here's the graph, and the questions are: what is the age at which they're the most hunters? Okay. Well, that's going to be this is age down here, and then hunters. Actually, write it this way, everybody can read it. Hunters. Okay, so hunters along the y-axis, the age of the people along the x-axis. What age is there the most hunters. I'm going to come up here to the top of this parabola, and it looks like around there. Does that look like the vertex of the parabola? Pretty close. Maybe it's one line over. Maybe it's this one. Maybe it's those. So what age does that happen at? Well, each of these tick marks appears to be worth 4 years. So 30, 32, 34, 36, 38, 40. Let's say it's right there in the middle and say that that is at 37. All right, so what age does it happen? 37 years or 38 years? Okay. How many hunters are there at that age? Well, if I come up here to my vertex and I shoot across, where am I at? Sometimes you just have to force it. There we go. Where does that look like it crosses? 32, 34, 36. Approximately 3,600 hunters. Okay, so this is quadratic. Okay, I drew the reason that line is extended all the way across there is just because I was trying to force it to be level. But these are the kind of problems we're going to be seeing in this section. I have a quadratic function. It's going to model something that I like or want. We have a name for this. What is this point? What does this point represent here? Is it a maximum or a minimum? Maximum or minimum? Maximum. Yes, it's a maximum, right? It's that point is highest. That's the highest value that I get out. The maximum is the 3,600, and it happens when x is 37. If you were to say 38 and still give me that 3,600, that would be completely right. But if I ever were to ever ask this question of you, I would have a graph that was much easier to read. All right. So if I've got a quadratic function, quadratics have these characteristics. Quadratic functions can be written in the form ax squared plus bx plus c, where a, b, and c are real numbers, and a is not 0. We've talked about this before. A can't be 0 because if a is 0, this whole term zeroes out, and I'm just left with bx plus c, and that's a linear function, so can't have that. Now, excuse me. So the sign of that leading coefficient a determines if the parabola opens up or down. On the previous problem, it opened down. If you look at the value of a is negative. So because a is negative, the parabola opens down. If a is positive, the parabola opens up. And if a is 0, it's not a quadratic function. The vertex of a parabola can be found exactly by taking b, taking that coefficient of the middle term, dividing it by 2a, and then sticking a negative on the outside. What that is, that's going to tell you where does the maximum or minimum value occur. And then once you find that value, you plug it into the function, and we'll give you that maximum or minimum. Okay. Number 3, easy points. Okay. Easy points for number 3. Axis of symmetry. Okay. The axis of symmetry is the line x equals negative b over 2a. you just found negative b over 2a because that's the x-coordinate of the vertex. The axis of symmetry means if I take the function or take my polynomial and I fold it over, it's going to land right on top. All parabolas have this axis of symmetry. Okay. Now, once I know the vertex and the axis of symmetry, I know if it opens up or down, then I'm going to find my intercepts. There's always going to be a y-intercept. Okay. There may not be an x-intercept though. Okay. The way to check that is to check the radicand, check that value under the square root in the quadratic formula, right? If what's under there is positive, I'm going to have 2 unique roots. If it's negative, I'm going to have complex roots. And if it's 0, I'm going to have 1 repeated root. Okay? So once you have these things figured out, y-intercept and an x-intercept, a vertex and axis of symmetry, does it open up or down? You'll determine the max or min because you got that from the vertex. Right? Okay. This will be the vertex. And then find the domain and the range in interval notation. For parabolas opening up or down, unless they tell us some issues for domain, a parabola is never going to give us one of the 2 issues I can't handle, which are, is x in the denominator, is x under an even root. These are almost always going to be the domain is everything, and then the range is going to be determined by does it open up or down, and then what is the max or the min. Okay. Another way to write a quadratic equation is as follows. I have f of x is equal to a times quantity, x minus h, closed quantity squared plus k, where h comma k is the vertex. All right, so you can write all quadratics in that form up above, ax squared plus bx plus c. Another way to write the quadratic is in this form. Why would we want to do that? Because remember with the linear equations, if I can get it into slope-intercept form, the general form of a linear equation looks like this: ax squared plus ax plus by equals c. If I can get it into this form, suddenly the slope and the y-intercept jump right out at me. Same thing here. If I can take f of x is equal to ax squared plus bx plus c, and I can get it in this form, rather than having to calculate the vertex using the negative b over 2a stuff, I can just look right here and say, oh, there's the x-coordinate of the vertex, there's the y-coordinate of the vertex. So that's the reason you'll see these in both forms. So let's just dive in and handle the first question. All right, so f of x is 1/2 quantity x plus 1 closed quantity minus 4. Okay, so how does it open, up or down? Well, tell me what a is first. Okay, can anybody tell me a without doing the math out? Right, x plus 1 times x plus 1 is x squared plus 2x plus 1. Distribute the 1/2. That's 1/2 x squared plus 1/2 times 2 is 1 plus 1/2 minus 4. And I'm looking at 1/2 x squared plus x. 1/2 minus 4 is negative 7/2. Yep, so a is 1/2. Which means a is positive, up. Okay, find the vertex. To do the vertex, I need to find b minus 2a. Negative b over 2a. For this one, b is 1. A is 1/2. That's frustrating. All right, so let's do the math. 2 times 1/2 is 1. 1 divided by 1 is 1, and this whole thing is negative. All right, so there's the x coordinate. Now find the y coordinate. Take my function and plug in what I just found. Well, that's -1, right? I just found negative b over 2a to be -1. Now I just take that x value, plug it into the function, and solve. Sometimes it's good to use the expanded form that you got. Sometimes it's good to come back to the original. Look at what happens if I go back to the original form. That's 1/2 times -1 plus 1 squared minus 4. -1 plus 1 is 0. 0 squared is 0. 0 times 1/2 is 0. So 0 minus 4 is -4. So that means my vertex is the point, -1, -4. Okay. Let's give ourselves some space. It's always a guess at how much space I need to leave between these. I think what I would do next is I would jump straight down to the axis of symmetry. You just found the x coordinate of the vertex. So the axis of symmetry is the vertical line that passes through the vertex. The vertical line that passes through the vertex is the line x equals whatever the x coordinate is for the vertex. Okay. Now, x-intercepts. Okay, how do I find x-intercepts? Well, if I want to find an x-intercept, I'm going to let y equal 0, and I'm going to solve for x. Right? Sound familiar? So, for us, f of x and y are the same thing. So that means I'm going to take my original function. I'm going to plug in 0 for f of x. And then on the right-hand side, I've got the whole function, and then I just need to solve this for x. This is x, this is something x plus 1 squared. I really need to isolate the x. So I'm going to put everything that has an x on the right, everything without on the left. So that means add 4. And now I'm looking at 4 is equal to 1/2 times x plus 1 squared. I would really like that 1/2 to go away. And I can make that happen by multiplying both sides by 2. Right? If I multiply the right by 2, the 1/2 goes away. If I multiply the left by 2, I get 4 times 2, which is 8. So now I have 8 is equal to x plus 1 all squared. All right. And now I have my squared term on the right. I have a number on the left. I want that square to go away. So what do? Come up here and do it. I want that square to go away, so I need to take the square root. So I take the square root of both sides. I took the square root of a positive number, or I took the square root of a real number on the left, so I do have to consider the plus and minus here. So on the left, I have plus minus square root of 8. On the right, the square root of the square is just whatever was being squared. Square root of 8 can be simplified to 2 times the square root of 2, because 2 squared is 4. 4 times 2 is 8. And then I need to get x totally by itself, so that means subtract 1 from both sides. And I'm left with what? I'm going to write it as -1 plus or minus 2 times the square root of 2. So all of that work to find out that my x-intercepts are what? They are -1 plus 2 root 2, comma 0. and -1 minus 2 root 2, comma 0. Those are the exact intercepts, right? If you ever see exact answer, that's what it wants here. A lot of people would tend to round this. I'd rather have an exact answer, but it all just depends. Really, which way you do it is going to depend on what the question that you're being asked is saying. How about the y-intercept? How do I find that? To find that, I let x equal 0, and then I solve for y. My original function is f of x is equal to 1/2 quantity x plus 1 squared minus 4. So now I'm just going to plug in 0 for x, and what do I find? I have 1/2 times 0 plus 1 squared minus 4. 0 plus 1 is 1. 1 squared is 1. 1 squared is 1. 1 times 1/2 is 1/2. 1/2 minus 4 is -7/2. Okay. So that means I have found the y-intercept to be what? I let x be 0, and I found y to be -7/2. Now I've got axis of symmetry is done, and then maxes and mins. When I have a parabola, there's only going to be one of these, right? When I'm dealing with a quadratic where the highest power of x is 2, I'm going to have one max or one min. I'm not going to have both, right? So based on our problem, right, we said, or based on this quadratic, this opens, A is positive, right? So it opens up. When the parabola opens up, that means the vertex is a minimum. All right, so I have a minimum, and then I have to, I'm going to type this part. So the minimum of, what is the y value of the minimum? It's -4. So the minimum of -4 occurs when x equals -1. So the minimum is that x value. The minimum is the y coordinate of the vertex. The maximum, when it occurs or where it occurs is the x coordinate. Let's put a little box around that. All right, we've seen domain before. And when I'm dealing with domain, I have two questions. They are, is there a variable in the denominator? Is there a variable under an even root? The answer is no and no. If the answer to both of these is no, then that means that my domain is all real numbers. I keep grabbing the wrong pen, that's why this isn't working. There we go. If the answer to both these questions is no, then the domain is all real numbers. How do I write that interval notation? -infinity to infinity. Now, the range. We have not been asked about the range before. Okay? What is the range? That's all the possible y values. Okay? All right, now, the vertex in this one vertex corresponds to a minimum. So the smallest possible y value is -4. Okay. So if that's as small as it can get, the parabola opens up. So it's going up. The lowest it gets is -4. The highest it gets is it goes on forever in that direction. So what is my range going to be? Well, my range the lowest I can go is -4, but I can go on forever upwards. So my smallest value is -4, and that continues up forever. So I have enough information to now sketch this function. All right, now I'm going to go steal a graphic here real quick. Bring it back to this one. So what do we know? All right, what do we know about this function? Well, I have a vertex at -1, -4. All right, -1, -4 is here. I am opening up. I have what else? So vertex is here. X-intercepts. I have x-intercepts at -1 plus 2 times √2 and -1 minus 2 times √2. This is when graphing that number might be a pain in the neck. So we'll figure out what these are. Numerically. 2√2 is 1 and some change. 2 that, so then subtract 1, 1.828, and then -3.828. So those are my two x coordinates. So let's find those. 1.828, so somewhere around here, and then -3.828, so about here. All right, got those. X-intercepts are plotted, y-intercepts are plotted, y-intercepts plotted. Axis, y-intercept, 0, -7/2. 0, -7/2 is 3.5. So I'm right there. And do I have anything else to plot? Nope. The minimum is the vertex. And now my graph goes up like this. Up like this. And now I've sketched my graph. So what did I label here? This is -1 minus 2√2, 0. This is -1 plus 2√2, 0. This is the y-intercept 0, 7, -7/2. And then this is the vertex, -1, -4. Now, here's where everybody starts to get frustrated. Okay, is that a perfect graph? Absolutely not. All right, it is not a perfect graph. But I didn't ask you for a perfect graph. I asked you for a sketch. All right, we're trying to gather enough properties and information about a quadratic so that we get an idea of what it looks like. If I wanted a perfect graph, I would just go graph this in some software. But instead, what I want to be able to do is, if I find all these pieces and put all of the puzzle pieces together, will I be able to see the original? And there it is, that's my sketch. Again, that is why this chapter is all about sketch the graph and not graph the function. Okay? So that's what 2.1 is all about. I have 4 questions in a row. They're the same thing. Okay? We just did the problem like the 3rd and the 4th here. So let's tackle this one and see if we can piece together everything we just did. All right, so what is g of x? G of x is x minus 3 squared. You know I'm going to have to find the vertex, so I need a and b. I can't tell you what a and b are right off the bat, so I'm going to go ahead and do the math here. X minus 3 times x minus 3 is x squared minus 6x plus 9. So here is my function. And if it helps, come out here to the side just to label your stuff. B is -6, and C is 9. Does everyone agree how I can't see this? I can't see this information if I leave my function in this factored form, right? So how does it open? A is greater than 0. So this opens up. I don't really care how much greater than 0 it is, just the fact that it is greater, right? A greater than 0, so we open up. What's the vertex? Negative b over 2a is negative 6 over 2 times 1. Negative 6 divided by 2 is -3. Negative 3 is 3. So there's the x-coordinate of the vertex. Now I need to find g at positive 3. I don't know why I wrote the negative. There were just so many negatives I wanted to take one home with me. G at 3. G at 3, you can go back to the original here. 3 minus 3 squared is 0 squared, which is 0. So that means I'm looking at a vertex of 3, 0. Okay. You can also plug 3 into the unfactored form. That'd be 9 minus 18 plus 9, which is 0. So you get the same thing. Now, quickly remember, let's do a little skip here. Come straight down from this. Once you found the vertex, the axis of symmetry is just x equals whatever the x coordinate is in the vertex. All right. Find x-intercepts. So I'm going to take g of x, let it be 0, and solve. X minus 3l squared is equal to 0. Solve this. Take square root of both sides and solve for x. All right. Square root. You can do positive and negative over there, but positive 0 and negative 0 are the same number. So I just end up with one of these. So x is 3. So let y be 0. I found x to be 3, so I'm looking at an x-intercept of 3, 0. How about the y-intercept? The y-intercept, what do I do for that? I take my original, I let x be 0, and I see what I get. 0 minus 3 squared. 0 minus 3 is -3. -3 squared is positive 9. So I'm looking at a y-intercept of 0, 9. I already found the axis of symmetry as soon as I got the vertex. And now, do I have a, let's see, maxes and mins? What have I got? I'm a parabola, I'm opening up. So that means I'm looking at a minimum of, and I already know the answer here. This is a minimum of my vertex was 3, 0. So it's a minimum of 0 when x equals 3. Just again, this is the vertex, right? If I'm opening up, the vertex is a minimum. If I'm opening down, the vertex is a maximum. And you'll hear me with my language there. I'm trying to be careful. The vertex corresponds to a minimum because, right, the maximum and minimums are the y values, and they occur when at the vertex. So if you hear me say those things, I'm trying just not to say anything mathematically incorrect is what we're doing. All right, domain. Were there any issues? Right. What are my two questions? Is there variable in the denominator? No. Their variable under an even root? No. So that means my domain is all real numbers. And then how about range? My range, well, the lowest y value possible is 0. Parabola opens up, so y's go up to infinity. And there's my range. So sketch. Let's go steal this. What do I know? I know that I have a vertex at 3, 0. I have, right, vertex at 3, 0, I'm opening up. I have an x-intercept at 3, 0. Hey, look at that, they're the same point. Right? The x-intercept and the vertex are the same. That can happen. So my y-intercept 0, 9. So 0, 9. That's going to be 6, 7, 8. It's going to be up here, right? Off my graph. And what else do I know? I don't really know anything else. All right, so this is 3, 0. And this is 0, 9. The vertex and the x-axis actually were the same here. So in this case, our list of values from above only gives us 2 points. You can find more if it helps. Okay, if it helps by plugging in any value you want for x and finding the point. 3, 0, and then 6, 6, 9. Yep, you got it. So this one only has 2 points. You can probably see how this is going to go, right? This parabola, it's opening up. I'm going to look like this, and I'm going to be symmetric over here, so it's going to do the same thing on that side. I didn't graph this last time, but a axis of symmetry is typically represented by a dotted line going through the vertex. And we said this is the line x equals 3. And by what I meant, that axis of symmetry, you'll agree that if I fold this across that axis of symmetry, what should happen is the graph on the right lands on top of the graph on the left. Does it do it perfectly here? No, because I sketched this. But yeah, if you're doing this and you wanted to get some more points before you sketched it, you can find, I've got the vertex and I know this point. If I wanted to find maybe what does it look like when I get to the right of my vertex? So maybe plug in 4, plug in 7, plug in 9. Any of those are valid, and you can actually find some other points here. So I just wanted to make sure you get the title right. This is g of x. X minus 3 squared. So for instance, let's try finding 4 minus 3 squared is 1 squared, which is 1. So 4, 1 is another point that I can look at. And then g at 6, 6 minus 3 squared. 6 minus 3 is 3, 3 squared is 9. So 6, 9 is going to be on there too, right? Because of our symmetry. Okay. All right, so we can stop there. I will continue this lesson on, I'll continue doing this lesson page by page, post the video up, and let you take a look at it. Then you can bring questions to class on Thursday, but I don't want to go any farther right now because the test is due today. So last call for any questions on the test before we end class today. Anybody got any other outline questions or outstanding questions? No? All right, well, I'm going to pause, or I'm going to stop the recording here.